we're going to talk about the regulation of metabolism in specific to insulin regulation. So previously we talked about how we got IRS1 to be phosphorylated. So IRS1 is going to be phosphorylated by an insulin receptor tyrosine kinase. It's going to occur through a phosphoryl transfer from the tyrosine residue, and that's how we get these phosphoryl groups. Now, these phosphoryl groups are going to bind to its SH2 domain of the PI3K protein, which is going to ultimately convert PIP2 to PIP3. This PKB bound to PIP3 is phosphorylated by PDK1, which is not shown in this diagram. Thus, it's activated. Now, PKB phosphorylates GSK3, which is active when dephosphorylated, and PKB will phosphorylate GSK3 on a serine residue, causing it to be inactive. So we need to make sure that inactive GSK3 will occur when it's phosphorylated. GSK3 dephosphorylated will be active. Now, GSK3 inactivated by phosphorylation cannot convert glycogen synthase to its active form by phosphorylation, so GS remains active. So GS, when GSK3 is inactive, this will not occur. So GSK3 will remain active, thus causing the synthesis of glycogen from glucose to be accelerated. Now, referring back to PKB acting through G proteins such as RIC1 and RAB stimulate the movement of glucose transporter GLUT4 from internal vesicles to the plasma membrane, which ultimately increases the uptake of glucose. So here we see glucose on the outside, and it's going to go ahead and increase the amount of glucose that's being taken up by the cell.